All right, Foundations in Math 11 here is video 4, and this video is just about puzzles. So what I'm going to do in this video is I'm going to introduce you to a few different riddles or puzzle scenarios, and then give you an opportunity to pause it, try to work through it, and then I'll do the solution for you. This section is all about just fluidly thinking your way through things and trialing and erroring and trying and failing and being resilient and battling and thinking. And it truly is the hard part, because this is where we kind of fall apart now, is that this is difficult because we could Google the answer, but finding the answer is a challenge. And there will be times where we need to find the answers to solutions that don't have, or the answers to questions that do not have solutions yet. So being able to think is a very, very human ability. So I urge you to try your best here. So here we go. Put the numbers 1, 2, 3, 4, 5, 6, 7, 8 in each of the circles so that each edge adds up to the same number. So as an example, you go 3, 7, 4, 5. That adds up to 19. So the other sides would also have to add up to 19. So you got to make sure that happens on each side. So if you want to try and figure this out, push pause now. Otherwise, here we go. Now, there are many ways to do this, but here's the way that I came together with. I first looked at my biggest numbers, 7, 8, and 9. And I figured I don't want them on the same arm, which means I don't want them in any of these circles. Because if I put 7 and 8 in there, that's a big total, so it'd be difficult for me to match that total. So my first thought process was, I'm going to put them here, here, here. So now I've put them in the corners, because that way they have an effect on each arm. Now look at the total here. 7 and 8, or 8 and 9 is 17, 9 and 7 is 16, and 7 and 8 is 15. So each side is one less than the other. And think about the numbers you have left. 1, 2, 3, 4, 5, and 6. Can you combine those numbers so that they equal totals one less than each other in sequence? So if you did, let's see, 2 plus 4, you get 6, right? So there's 2 and 4 gone. 6 and 1 is, so 2 plus 4. 6 and 1 is 7. And that leaves me 5 and 3, which is 8. So I have that scenario where I have one more than the other 3 times through. And what we do is we just put the higher number. So 8 would match up with 15, 7 would match up with 16, and 6 would match up with 17. So 2, 4, 5, 3, and 1, 6. And you can see that now your totals are going to be 8 and 15, so 23, and then 16 and 7, so 23, and then 6 and 17, so 23, and boom, we've done it. So that's just one way. There are a number of different ways. Some people just like to plug through and try, and I urge you to see if you can come up with a different solution. So here's another puzzle. This is taken from a really popular TED-ED Riddle that I like to do with my class, and the gist is you have a group of people trying to escape a horde of zombies, and they have to cross a rope bridge. And you have all 4 of them over here, okay? There's 4 of them here, and it takes them different amounts of time to cross the bridge. So you can see that it takes you, the intern, 1 minute to cross that rope bridge. It takes the assistant 2 minutes to cross the rope bridge. It takes the custodian 5 minutes, and it takes the old scientist a full 10 minutes to cross the bridge. And the scientist has done the calculation that the zombies will catch up to you in 17 minutes. So can you get your group across in under 17 minutes? But there's a caveat to it, because it's so dark that you have to carry a light while crossing the bridge, which means you have to stay together while on the bridge. You can only put 2 people max on the bridge at a time or it'll fall. And they have to walk together across the bridge carrying the lantern, because if they don't have the lantern, it's too dark. And that lantern needs to go all the way to that side, and then it needs to be brought back before you can bring the next people. So if you want a good video representation of what this riddle entails, just go to YouTube. Well, you're on YouTube. So just click through YouTube to TED-ED Zombie Riddle. And that's what you're trying to solve here. So try that. You need to get everyone across in 17 minutes and pause. Okay, so here is the solution. So you need to pair people up. And oftentimes when people start to go, they go, okay, I'm going to take the fastest two people. So 1 minute and 2 minutes. And they run over to that side of the bridge. And it takes 2 minutes because you need to match the slowest person's time. But you need to bring that light back. So what happens? Well, obviously the fastest person brings the light back, and that's another minute. So now we're at 3 minutes. And then most people's brain thought goes to, okay, well, now I'm going to go with the old man. We're going to run over there. But since you're really fast, your time is negated by how old the scientist is. So it takes a full 10 minutes to get across. And then sure enough, again, you're going to have to run the lantern back. It's another minute. So far your total is already at 12, 13, 14 minutes. And who's left over there? The 5-minute person, which is going to kick you to 19 minutes. That's no good, right? So a lot of people try that first scenario and then their brain just stops working. And they can't think of any other scenario to try. And maybe they try by substituting the custodian for the scientist and vice versa, or they send the two slow people first, but then you're already at 10 minutes and you can't get the lantern across. And the idea here is to maximize time, but also to maximize slow time. So the starting idea is not wrong. Send 1 minute and 2 minutes together. It's going to take them 2 minutes to get there. And then obviously, yeah, you need the lantern back. So why not send the fastest person back, right? Send back the 1 minute person. So far, we've taken 2 minutes and we have number 2 waiting over there. We've taken another minute and we have 1, 5, and 10 over here. So here's where most people fail to make the connection. No matter who goes with the 10-minute scientist, it's going to take 10 minutes. So you might as well send 5 and 10 together. That leaves the 1 minute on the one side of the bridge. Because then sure, it took 10 minutes. And yes, you have to bring the lantern back. But who's waiting on that side? The 2-minute lab assistant. So the 2-minute lab assistant runs the lantern back. It takes 2 minutes. And then who's left on that side? The 1-minute runner and the 2-minute runner, and they just run back together, and it takes another 2 minutes. So how long did that take in total? It took 2, 4, 6, 16, 17. So we got everyone across in 17 minutes. So 2 minutes, 1 minute, 10 minutes, so 3, 13, 14, 15, 16, 17. So yeah, the caveat from the riddle, I wrote this down by memory, is in 17 minutes. So you have 17 minutes max, not under 17 minutes. That is as quickly as you can do it, 17 minutes. But the idea here is to think about maximizing time by sending the slow ones together. So, and this is a trial and error scenario, right? Like send 1 and 2, or send 1 and 5, or send 1 and 10, but try different versions of who you're sending with whom, okay? Again, this is on YouTube, TED-ED Zombie Riddle, if you want a nice comic animated rendition. So here's another one, okay? This is a classic from the movie Die Hard with a Vengeance. Bruce Willis and Samuel Jackson have to solve this riddle. And here's the riddle, okay? You got a jug here, okay? And in this jug, you have room for 5 liters of water. And you can't see through the jug, and there's no measurements on the jug. You just know that it holds exactly 5 liters. And then you have a smaller jug that holds exactly 3 liters. And again, you can't see through the jug. There's no labels on the jug. And then you got maybe a hose, right? You got an endless supply of water. So you can fill the jugs up. You can dump the jugs out as much as you want, right? And you need to get exactly 4 liters in the 5-liter jug. So how do you do that? So if you want to think about that and try and work your way through that, push pause now. Okay, so here we go. There's actually multiple ways to solve this, but if you look at 5 and 3, you can empty and fill that 3-liter jug as much as you want. So really all we're trying to do is get to a point where we have 1 liter somewhere. Because if we can have 1 liter, we just add 3 liters to it and we have 4. So how can we do that? Well, If you fill up, let's do it this way. Here's the contents of my jugs, okay? They're both empty. And then I'm going to fill up my 5-liter jug. So now I have 5 liters, I still have 0 in my 3-liter jug. And then I'm going to dump my 5-liter jug into my 3-liter jug. So now I have 2 liters left there and 3 liters left there. So what can we do with that? Well, why not pour out the rest of your 5 liters? So now you have 0 and 3. Because your 3-liter jug is full and your 5-liter jug is empty, right? So what happens now if you fill up your 5-liter jug? Well, that doesn't help. We're back to 5-3. So let's rewind. We've poured 3 liters out of our 5-liter jug. Let's empty our 3-liter jug. Because now we have 2 liters left in the 5-liter jug. So now if I pour the 2 liters out of the 5-liter jug into the 3-liter jug, I have 2 liters left in the 3-liter jug. And I have 0 in my 5-liter jug. And alarm bells should hopefully be going off in your brain right now. Because now if you fill up the 5-liter jug full, you have 5 liters and 2 liters. How much room is left in the 3-liter jug? 1 liter. So if you pour 1 liter out of the 5-liter jug, you have a 3-liter jug full. Who cares about it? You have a 5-liter jug with 4 liters left. So that's one way to do it. There is a second way to do it. I will let you try to figure that out on your own. And if you do, congratulations. Now here's one more. This is also, or one more that I'm going to demonstrate here. This is also a TED-ED riddle. This is the TED-ED Passcode riddle. I really like this one as well. So in this one, it involves having to determine a password to escape a hallway. Now I've adapted the write-up here slightly, but you're in a dungeon and there's a whole bunch of exits out of this dungeon. And there's a little passcode pad on the wall. And you can input digits 1, 2, 3, 4, 5, 6, all the way up to 9. It's a digit passcode. And you get summoned up to the warden's office through one of those exits. It doesn't lead out, but it leads up to the office. And it has a hallway number, and you see what that hallway number is. Okay? Now, when you're up there, the warden says, okay, if you want to leave, the actual exit has a passcode that is made up of 3 digits in equal or ascending order, which means they can look like that, right? That would be equal here and then ascending there, or 2, 3, 6, right? Those are all ascending. You can't have something like 6, 3, 1 because that's descending. Okay, so your numbers have to either equal or increase. And their product is 36, which means we have a number times a number times a number, which is 36. So that's what's being told of you. And then the passcode is also made up of the 3 digits whose sum, so A plus B plus C, is the same as the hallway number that you came up, which you know, but we don't. And then being a perfect logician, you need the 3rd clue. Now, I'm going to change the you and whatever. Let's just say you know the hallway number, but you need to relay this info through secret radio to some other people. They're listening, okay? You can't say anything else. That's what they do in the riddle on YouTube. So you need the 3rd clue. And the 3rd clue is the largest number appears only once. Okay, so where do you start? You need 3 numbers that multiply to 36, 3 numbers that add to an unknown hall number that the person getting the clues knows. But then for some reason you need the 3rd clue, that the largest number is unique. So go from there. Okay, so how do we start? Well, if our passcode is numbers that multiply to 36 and they're numbers 1 to 9 and they need to be in ascending or equal order, let's write down the possibilities, okay? What multiplies to 36? Well, 1 times 36. Well, what else? 1 times 2 times 18. Yeah, but that doesn't work because we don't have an 18 button. So 1 times 3 times 12. Yeah, that doesn't work. We don't have a 12 button. Okay, so what about 1 times 4 times 9? That'll work. 1 times 6 times 6. That'll work. And now we're stuck because we won't ascend anymore. So now let's change our leading numbers. So how about 2 times 2 times 9, or 2 times 3 times 6. And I believe that is it. So now let's change our leading number again. 3 times 3 times 4. And remember, they have to be the same or increase in size, which means it limits our options. Can we do 3 times 4? Nope, because then it would be 3, 4, 3. And 3, 6, 2. So I believe that's all we get for 3, 3, 4. And that's it. That's our list. So the second clue is that they add to the number of the hallway that we just came up, or that the person just came up. So if we now add all these together, because these are our potential, oh, and sorry, 1, 1, 36 won't work either because we don't have a 36 button, right? Silly, silly me. So we have 1 times 4 times 9. So we add these up, you get 14. You get 13. You get 13. You get 11, and you get 10. So you'd think that the person that went up the hallway knows what the hallway number is. So you could just pick the one it is. If the hallway was 10, you're out. 14, you're out. 11, you're out. So therein lies the dilemma and the need for the third clue. Both of these have the same result, which means you know that the hallway that was gone up was hallway 13. But what's the passcode? Is it this one or is it this one? And that's why we need the third clue, that the largest number must be unique. And 166 does not have a unique large number, so boom, there is your passcode. Again, I threw this in to try and just have you access it right here, but it is the TED-ED Passcode Riddle on YouTube, and it's really has a animated little story behind it as well. So again, it's a good one. There are a ton of them on there, but be wary because they can be quite difficult. So let's do another one here. So we got, this is kind of your classic question where you have a list of numerals, in this case 1996, and can you combine them in an order to make 28, 32, 35, 38, 72, and 73. And what you have to do is you can use any operator symbol, so plus, minus, multiply, divide, square root, exponents, and you need to just create an expression that will equal the given number. So take some time to work through this one. You're probably going to push pause for a while, have at her, see if you can make all of this work, and push play when you're ready to get the solution. So you can manage these in a whole bunch of different ways, and I urge you to try and be creative as best you can. I'll just show you the ones I came up with. So for 28, I took 6 squared, and then I subtracted the product of root 9 times root 9, and then plus 1, because that's 36 minus, root 9 is 3 times 3, plus 1. So that's 36 minus 9 plus 1, which gives you 27 plus 1, which, look at that, you get 28. So that's the approach I took. And again, you may be able to find another one. You could get creative. Next one I looked at was 32. So I took 1 and I divided it by the square root of 9, which means 1 over 3. So you have 1/3. And then I multiplied that by 9 and 6, the two remaining digits, written as the number 96, and 96 divided by 3 is equal to 32. So there's that one. For 35, I took negative 19, so 1 and 9 together, plus 9 times 6. So that's negative 19 plus 54, which is 54 minus 19, which is indeed 35. So those are my first three. And again, there may be other ways to do this. You can get creative, and you can get there's some interesting puzzles on this one sometimes where it's like, I think it's, you take 4 sevens and you try to get every number between 1 and 100. So you can do these to your heart's content. So for 70 or for 38, I took 19, because 19 times 2 is 38, right? But I don't have a 2 anywhere. But if I can get 19 divided by a half, that's the same as 19 times 2. So I did 19 divided by the square root of 9 divided by 6, because that is 19 over 3 over 6, which means 19 divided by 1/2, and that gets me 38. For 72, I took 1 plus the square root of 9, because that's 4, and I multiply that by the square root of 9, which is 3, and 6, because 4 times 3 times 6 is 12 times 6, which is in fact 72. So you get quite creative. The square root symbols really come in handy. And then for 73, 9 plus 9 times 6. 19 plus 54 is 73. So have fun with that. There's a number of different ways you can get there. Do your best. All right. Thanks so much. See you in section 2.